Hey guys, it's Mr. Calderon with Queen White Pawn. In this video, I will be discussing why the radian is important, what is a radian in the first place, how to convert between degrees and radians, and applications of the radian. So first of all, we ought to discuss what the radian is. Let me go ahead and share my screen on my tablet so I can illustrate to you the definition of a radian by itself. So here we go. Let's say that I have a circle, just like in the previous video. And this time I'm going to draw a radius from the middle of the circle. And we'll call this distance r. So I walked from the middle of the circle to the edge. That's the distance. How long would it take me to walk from this point and around the circle, walk the exact same distance? So it might look something like this. And you can see that both r's, they're the same distance, more or less. And if they are, then this degree, this angle right here, the degree of separation, that would be called 1 radian. We'll put the angle there, theta, and theta would equal 1 radian. So the radian is the amount of separation such that the radius equals the arc length. This right here in yellow, that's the arc length. Okay, an arc is something that's curved. It's a curved line. And when the curved line, the arc, its length equals the radius, the angle is a radian. So let's draw another arc length again, where the arc length is the same as the radius. And let's keep going around the circle. So that's another one. So this one's r, that one's r. So far, we've done 3 radius lengths around the circle. And then we go again. And then we have 4. But let's look at right here. Let's pause for a moment and look at down the middle. So you can see I drew a red line down the middle. As you can see, I've done 3 radiuses and a little bit more. It turns out that this distance right here is 0.14 of the radius. So basically, after going halfway around the circle, halfway around the circle, I've gotten 3 radius lengths and a little bit more. It turns out that the distance halfway across the circle is pi radians. So you could say in orange that 180 degrees, which is halfway around the circle, equals pi, or 3.14 radians. So if I were to go 360 degrees, well, I know that 360 is twice 180. So I would just write 2 pi radians. And if I wanted to do something like 90 degrees, well, I know that 90 is half of 180, so I would get pi over 2 radians. And this is how it looks like in the blue on the lower corner. If I have 180 degrees, and that equals pi radians, then 90 degrees is half of 180, or 180 divided by 2. So I would write this. That equals pi over 2. And you can play with this as much as you want. For example, let's keep going. And if I got 180 equals pi radians, that's always my starting point. And I divide by 4. So I only go that much. Then this answer will give me the degree of what this is. Turns out that this is 45. So 45 degrees equals pi over 4 radians. And that makes sense because 45 times 4, 180, that'll give me pi. Now that I've run out of space, let me clear the board. Suppose that I have 135 degrees. How much is that in radians? What goes in the blank? Well, your first step is to always start at the reference point. So I have 180 degrees equals blank. Well, I know that it's not a blank, actually. I know that that equals pi radians because it's my reference point. Well, if I find out what number goes into 180 and 135, I would find myself one step closer to the answer. It turns out that the biggest number that goes into that, it looks like it's 5, but then as you go further, you get not the simplest answer. So we divide 180 and 135 by 5 on each side, you get 36. Sorry, not 36. You get 27 over 36. Because 5 goes into 135 27 times, 5 goes into 180 36 times. And you can obviously divide that by both by 9. So that gives you 3 over 4. Well, that means that this should be 3 over 4 radians times pi. 3 over 4 pi radians. 3 over 4 pi. That's the answer. Now let me show you maybe a less complicated way of converting. So let's say that we have 70 degrees and you want to convert that to radians. Well, you know that you have 180 degrees in pi radians. So that'll give you 7 over 18 pi because the degrees cancel out right there. You can cancel out units when you're doing this. And you got 70 over 180, but the zeros cancel out. So you get 7 over 18 pi. This works with any number. Let's say that you want to go the other way around now. And you got, let's say that you have this instead. 7 pi over 6 radians. And you want to convert that to degrees. Well, you put the unit you want to get rid of on the bottom. That's radians. And you know that pi radians equals 180 degrees. The radians cancel out, and so does the pi. And then you get 180 times 7 over 6. That number turns out to be 210. You can do it without a calculator. But if you need a calculator, you can do that. But you shouldn't need a calculator for that. Another trick to do is this. So far, we've looked at 2 ways to convert. Here's another trick. In that trick, 7 pi over 6, well, you know that pi over 6 equals 30 degrees, since 180 degrees equals pi. Well, when you divide by 6 on both sides, look at that, you get 30. And you have 7 of them. So 30 times 7 is 210. So I've given you 3 ways to convert. Pick whichever one is the easiest for you, and I think you'll do just fine. Now, let's find the arc length of something. So if we want to find the arc length, I think I'm going to do a separate video for that, which is coming up right after this one. So as I've always said, If you like this video, make sure to click the thumbs up button, subscribe for more content like this, and I'll see you in the next one.